Okay, so that's a linear system as we saw before, because this one has two equations, not just one. That makes a linear system. So we need curly braces to join these two together because they're linked, they're related, so they form what we call a linear system. Okay, so we need to solve it using the substitution. Okay, substitution. Substitution method. Last time we used a method to solve linear system. What was that method that we used? We solved the by. Remember when we had a system with two equations, what did we do with those two equations to find the solution? The solution was the intersection or the interception of the two lines. What did we do in order to find that solution? Does anybody remember from last time? We had a system like this and we solved it, but not by substitution, but by graphing, right? You guys remember that? A couple of days ago. So we took an equation in the system and we graphed both lines on the same graph and we got the solution. You guys remember that? We did line 1, line 2. So yeah, that's by graphing, okay? By graphing.
Yeah.
Okay, but today we're doing another method. As I told you last time, there was other methods. There were other methods. This is one of them. Substitution. We have another one called, what is it? Elimination. So today we're doing the substitution method. Not by graphing, but by doing the substitution method. So how to do that. So basically, we're going to find one of the variables. We'll substitute it into the other one. So let me write the system again. So 1 over 2 x minus 1 over h. And the other one was 1/3. How do we get rid of all these fractions?
Simplify.
How do you do that exactly? How do you simplify?
You would have to find the common denominators, which
That's
is...
right. Very good. We're going to find the common denominator. And we're just going to times all of them by the common denominator. And you'll see that all the denominators will magically disappear. What is the common denominator for 2, 8, and 4?
2.
Not quite.
4?
All of them must go into it. 2, 8,
Oh, yeah.
and 4 must go into it. What's the LCD?
Well, no.
2?
2 can go into 8, 4 can go into
No,
8.
the other way. All of these should go into it. 2, 8, and 4 must go into the LCD, the least common denominator. What number?
6.
Try the higher of all of these and see if it works. Do they all go into the highest of all these?
8.
That's right. If they go into it evenly, then that's the LCD. So the LCD is 8. If 8 doesn't work, then you try some higher number. It cannot be a smaller number than the highest one here. Okay, it's not 2, it's not 4, because 8 doesn't go into 2. So try the highest one, 8. All of them go into 8, so that's the LCD. All right, so once you find the LCD, it's very easy to get rid of all the fractions. Just put 8 times all of them by 8. Times all of them by 8. And you'll see what's going to happen here. Let me write the system again. Oops, not this color. Okay, so over here, what's going to happen is it's going to reduce. Before actually multiplying, 8 and 1x, we reduce 8 by 2. That will be, now we're reducing, we're basically dividing. What would that be?
You're dividing, right?
That's right.
Yes, 4.
That is 4.
Yeah.
Maybe 4. times what? Times this,
1.
whatever that is.
1.
Good. Next one, same thing. What do you do?
8
It's
divided by 8, 1
That's right. So
times
8 and 8
1
cancel out.
y.
1 y.
One.
Like
Exactly. What about the third one?
1 y.
And
It's 2.
2,
Multiply, right?
2 minus 1.
And 2.
Cancel these two. That would be 8 by 4 would be 2. So negative 1 times what?
2.
Times 2. That's it.
And times 1.
That's right. All these fractions are gone. Let's do the same thing and get rid of all these fractions. What is the LCD for the second equation?
12.
12
Exactly the highest of all of them. What do we do with the 12?
Divided.
divided by
Divide on all of them.
all of them, yeah.
Multiply, right? So we're gonna,
Or multiply and divide, yeah.
that's right, multiply first, and we actually divide in before multiplying. Okay, so we're gonna write the 12 again next to each one of them. Here. And also here. Okay, so let's reduce the first fraction. What do you get from here?
2.
12 by 3. That would be,
4.
4
that's right, it would be 4. 4 what? 4 times,
4 times
1x.
that's right, times 1x.
1x.
Then what happens to the next one?
1. 12
And 1 y.
divided by 12. 1 y.
That's right,
1
12 by
y.
12 is 1 times
Y.
1y or y.
1 y.
Equal
And finally here,
Equals minus 1 times 2.
2
that's right, 12 by,
minus 1 times 2.
that's right. Okay, so that's, if you see a lot of fractions in equations, first want to get rid of them, the equation becomes a lot easier. All right, so now we can actually multiply. We can actually do the multiplication. So this turns into 4x minus y
4x minus 1.
negative 2, and again 4x minus y, which is also negative 2.
Negative
Same
2.
equation. What's up with that?
Equal?
What do you guys think of this? So we're trying to solve this system by substitution, not elimination. If it was elimination, we would just add them side by side, but substitution. So the method of substitution means we're going to substitute one of the variables into the equation, into the other equation. But in order to do that, we need to isolate one of the variables. So let's get one of the variables by itself, maybe here. Let's try to get maybe y by itself. So isolate. Isolate a variable either equation. Which variable you want to isolate? Could be x or could be y. So let's say you want to get the x by itself. So what do you do to isolate this for x? Say 4x minus y is negative 2. You could decide to isolate either one. Let's say you want to get the x by itself, so we're going to move the y over. So 4x equals what?
equals
So x.
minus 2.
That's y minus 2, right? Positive y, if we moves over. Then what do you do to isolate the x?
Minus 6. Oh, no.
We have 4 here. That's a 4.
Oh. Minus 2.
Now we want to isolate the x here. We have 4x. You want to get the x by itself. So what do you do to get the x by itself?
You gotta divide, or you gotta put the 4 to the right side.
So I'm going to divide the entire thing by 4. So these two cancel. X is
1.
y by 4, which is negative 1/2. So again, because it's the method of substitution, we have to do this. If this was by elimination, we would just subtract the equations one by one. Everything would cancel out, and it will be many solutions. But if it was by graphing, we would graph them. But this one is explicitly asking us to use the substitution method, and this is how it works. We got rid of all the fractions. That's good. But now we're gonna need to get one of the variables by itself, which we did. That variable will be substituted. Hence the substitution method. So the system becomes what? X minus 1/2. So we isolated the X in the first one. Let's keep the first one, the second one the same. So the second one, we didn't change it, even though it's technically the same equation, but we didn't change it. It's not always, by the way, it's not always the case you're gonna end up with the same equation here. This is just a coincidence, just a special case. It's not always this. Most of the time, it will be two different systems, two different equations in the system. Okay, so isolate, which we did. So now that we're isolated, so we isolated one of the variables. The variable that you isolate, it goes into the other equation. Okay, so we're going to substitute the X into the other equation. We're going to substitute in this equation here. And once we substitute it, we will solve for, we're going to have Y left. The X will disappear. It will turn into a Y. We're going to have to solve for Y. Okay, so plug. So plug X into equation to equation 2. This is equation 1. This is, of course, equation 2. So now let's take equation 2, and this is the variable that we substituted. Okay, we're going to plug that into this equation. So it would be 4 times, what is X again? Instead of the X, what do we write? So instead of this X, you're going to substitute it with what's X equal to, which is basically this. Okay, so what goes inside the parentheses here?
Y over 4 minus 1 over 2?
Exactly. So we remove the X. After we isolated the X, this is the value of it. Then we substitute the X into the other equation. So instead of the X, which is this, instead of the X, we're using, we're going to put this Y over 4. Okay, so again, this is equation 2. Okay, this is equation 2. This is equation 2, so 4 and X, then the rest of the equation minus Y negative 2 equal negative 2. Okay, all we did was substitute the X. This is basically the X. So the X that's here is basically this. It's here now. That's the X. So instead of the X, we used this because X equals that. Okay, so let me go back. And what happens next? We still need to solve, right? So the equation is to solve each system, and solving a system means finding the value of X and Y, both of them. So what are these? So we're going to find a solution, which is a pair of X and Y. So we still don't have any. So first we got rid of the fractions. We isolated one of the variables, plugged that variable into the other equation. Now, can we solve this equation? How many variables does it have? This equation here. I mean, not variable, how many unknowns? There's only one of them, right? Only the Y.
Only Y, yeah.
All right, we can solve this easily. Initially, we had X and Y. We couldn't solve it, but we could still solve it. But we wanted to get rid of one of the variables, one of the unknowns. So once we plug the x is no longer here. Instead, we have the y's. So now let's solve that equation. What do we do to solve this? What's the first thing you do to solve this equation? Everyone, am I talking to someone here? I'm talking to myself.
Remove the.
You could go ahead and do it, Professor.
Yeah, I don't want people
Parentheses,
to. I don't want to do it for myself. Everybody else, are you guys here?
I'm just watching.
Yeah,
I
we
don't
are
understand.
here.
Okay, so please interact with me. Okay.
Yeah, yeah.
Sorry.
Okay, I feel like I'm talking to one person.
I personally say remove the parentheses. You gotta get rid of that.
All right. So we're gonna distribute. So 4 times y over 4. I mean 4 times y over 4. That's right.
Why is my camera off?
4 times negative 1/2 minus y and negative 2.
Negative 2.
Now, what do we do with this?
You multiply
cancel out
4
4?
by
Not multiply.
Divided
Divide. Cancel. That's
1y.
minus. What happens to this one now?
You
2
cancel
left.
4 and 2 and just write 2.
Minus 1
Exactly. So we can
and 2.
cancel. So it's 2 times 1. Bring the y down. Minus y. And negative 2.
Negative 2.
Okay.
Wait. How did that become 2.1?
2 by 1.
2 times.
Times 2.
Okay, well, how did
This is a times. 4 divided by 2 is 2.
2 and
Right.
then you leave the 1.
That's right. Just like here.
Okay.
4. Okay. So now, what do you do after this? Okay, so we're
Isn't
trying.
it 2? Isn't it like 2y
Close. It's not 2y.
or y to the second? No.
Tell me what happens to the equation here. Okay, like this.
It's negative y, isn't it? Negative y minus 2 equals negative 2?
Yeah, it's y minus 2 minus y. What else?
You cancel out y.
Exactly, cancel them because it's a y and a minus y.
Y.
Yeah,
Negative 2.
That's a special one, as I told you earlier. What does that mean? Is this a valid statement or not?
It says 0.
This is
Is this valid or not? That's a valid
Yes.
statement, right?
It is valid because they're both the same number.
That's
It's
right.
equal
That's
to each
valid.
other.
So when you get a case like this, it's called an identity equation. Identity equation. Identity. And this is a special one. Okay. When you have an identity, the x is gone, the y is gone. When you have an identity, how many solutions do you think we have? Let me say it again. So we have many solutions. What does that mean, many solutions?
Infinity and beyond.
Oh, that's right. On how many points do the lines meet? If it's many solutions. Again, think about last time when something interesting happened when we draw the lines. The last example. So the lines meet everywhere. If you remember with this, basically they meet all the points. All the points are common.
Yeah, we did touch that.
All I wanted to hit was the lines overlap. You remember that from last time?
That's right. You did say that.
Yes.
They overlap.
So,
Professor, did you record the last session because I missed that class?
actually, yes. I believe. Yeah, I sent you that video. It's the first or second part.
Check it out.
I think it's
Yes,
the second
I
part.
saw that.
You see it?
yeah, we got it in there now. Yeah.
Okay, so.
I didn't get it. I didn't get it.
Check your ML.
Nice.
Send
Yeah. Email.
Message, mail. Yeah.
Yeah, it's in the email.
Oh, you mean the YouTube link? Okay.
Yeah.
So this one pretty much summed up a lot of stuff. This question here.
It does have a lot of stuff.
Yeah. So this is because that's what the question said. There are other methods, but it said by substitution we had to use it. If it's said by graphing, we would use like we did last time. We can easily graph it and find the intersection or see if the lines overlap. There's also the method of elimination, but since it says substitution, we have to use it. What else? Okay, does that make sense? Any questions about this so far? I try
Does
to
it make
squeeze
sense? Or it makes a little bit of sense.
just a little bit of sense. Not
It's
a lot.
manageable. It's manageable.
Okay, okay.
Yeah.
I try to squeeze the answers out of you instead of just me writing and talking to myself. I want you to guys, you know, I want to pick your brains and get the answers out of you.
No, there's nothing wrong with that. It's just there's a lot of steps in this problem.
Yeah, it was long. Yeah, that definitely.
There's a lot. There's a lot to do in it.
That's right.
But it's fine.
But
Yeah.
remember the main steps here.
Yes.
Just cancel.
Yo, no, when you explain, it's good, easy to understand.
Yes,
you know?
exactly.
All right. So remember, you cancel the fractions. Isolate. That's the main step. And substitute. Okay, sub here. By the way, you're not required to do this. This is not, the answer is basically here. Many solutions. Does not ask you to do the graph. Okay, I was just trying to challenge you. This is not part of the question. So the answer, the question ends here. When you have an identity, you say many solutions and you stop. So cancel fractions. So 3 main steps here again. So you gotta cancel the fractions, which we did. So isolate the variable and then substitute that variable. And of course, solve. Okay. It would be, depending on the system, if you didn't have fraction, it would be a lot easier and faster. But basically, these are the main steps here. Okay, just to recap, the lines, if they meet once, you have one solution. By the way, yeah, okay, so one solution here. If they don't meet, if they're parallel, no solution. You may end up with something like that. Or
Okay.
if the lines overlap, that means they met everywhere. We have 2 minute solutions. And the lines don't stop here, they keep extending. The lines are extended in both directions. They do not stop here. And that's why we have many solutions. Another trick is, another hypothetical situation is, instead of okay, so instead of having an identity like this, let's say instead you got maybe -2 equals, let's say, 5. This is a hypothetical situation. What do you think about this statement? I'm going to challenge you. I'm going to give you a little hard time about this one, but I'm sure you will get it. What do you think about this statement here?
In terms of the graph then?
No, forget about graph and everything.
Oh,
If
okay.
someone said to you -2 equals 5, how do you take that statement?
You're looking for,
No, forget
what?
about everything else. Forget about all the lines. All that stuff. I'm just asking you, just like if someone said -2 equals 5, what do you think of that statement?
what I think about that statement.
In terms of its validity. Will you accept that if someone said -2 equals 5?
No.
No.
So what do you think about the statement? In
Like,
terms
you mean if you was to graph it? What do you mean?
no, don't graph. Forget about graphs and lines. Just the statement itself. What kind of statement is it?
It's incomplete.
Not incomplete. What's the right word?
The right word.
False.
Unsolvable?
Not unsolvable. In terms of the validity or the truthfulness of the statement.
What's it
Ooh.
missing? I don't know.
Is
If someone said, "Oh, $5 is the same as $20,"
It's false.
exactly false. It was a very difficult word to come up with, right?
Yes, it is.
I hate you. Oh my gosh, I hate math.
That is very hard.
Yeah,
You do not hate math more than I do.
So-
You know you don't.
So here, you see here, see it's valid, right? Or earlier, this statement was valid. Simply here, false or invalid, or if you want to be fancy, you can say absurd or
Oh God.
something like that.
Ridiculous.
Or ridiculous. That's
I
also a
said
good word.
non, you know, she said unsolvable.
Not-
That could have been
yeah.
still,
No,
yeah,
it's not
still, man.
unsolvable. You said incomplete. You said incomplete. I don't think that's the right
It's
word.
not
Anyway,
the same, like false, yeah.
no. So this statement is invalid. -2 is actually not equal to 5. It's what we call in math an
It's
absurd
not
statement.
true.
Invalid or not true or false, as you said, false. Or also absurd. Absurd. Something along those lines, right? Okay, here's another challenging one. Okay, well, only one question. How do the lines meet? Not meet. How do the lines behave here? If this is a false statement, are the lines, do they intersect? Are they parallel? There is no solution. Or they overlap and we have many solutions?
Parallel, no solution.
Parallel, no solution. Very good. That's the case where you say no solution. So these lines will never meet. That's why you get some crazy statement like this. This is literally crazy in math when you have an absurd or false statement like this. So false. We'll write that better. And absurd. Again, we may get
That
disconnected.
was not better.
Huh? I'm sorry, say it again, Jeremy.
No, you said you're going to write this better. You cross out fake and you say you're going to put false. That was not written better.
Maybe a little bit. Maybe a little bit. I'm trying to rush because I'm looking at the clock.
We
Anyway.
have less than 1